Okay, hello everyone. So today we are going to start a lecture on that is triple integral, that is of unit 4, right? We are going to start a lecture on this particular thing. So previously we have solved problems on double integral. So what is this triple integral? Triple integral, right, is essentially a method, right, to find volume. Right, basically we use triple integral to find volume, but however we can do many other things with triple integral, right? So let us see the concept, right? So notes have been provided to you people. Yeah, so triple integral. So what I do is, let us consider a function. Okay, so my function consists of what, that is variables x, y and z, right, which is continuous at every point of a finite region V. Now in the previous section it was only 2 dimension. Now it is now your concept has realized to 3 variables. Here any point P can be expressed in the form of x and y, and here any point P so any point in this 3 dimension figure, it will be, that is x, y and z, right? Okay, fine. Now which is continuous at every point of a finite region V of 3-dimensional space. Now the integral of f of, that is a given function in 3 variables x, y and z, where z contains x and y contains x, and x contains some constant value, right, over a region V denoted by, that is integral, that is triple integral over the, that is, in this time we are not calculating the region but volume of f of x, y, z over some dv. Now what is this dv? That is, dv is nothing but it is dx, dy, dz, that is some part of this, that is along x, y and z coordinates, right? Okay, so if it can be expressed as a repeated integral over the given region of integration in space with the limits that x is ranging from a to b, that is constant, and y is ranging from the limit, that is f1 of x to f2 of x. Okay, y is a function of x, and z is having the limit, that is phi of phi1 of x comma y and to phi2 of x comma y. Therefore in general we write the given equation, that is the volume with its limit, that is phi1 to phi2, which is expressed, that is in terms of x and y, and f1 is f of x, and this a is constant, that is we are evaluating it for the given function over, that is dz, this is dy, and for the constant values, that is a and b, that is dx, right? So let me consider this as my equation 1. Now rule to evaluate that is this equation 1, and I have written something like, that is formulation may change, that is at certain instant this might be y, and it can be expressed in terms of x and z also. So that is the reason I have written formulation may also change depending upon the geometry, right? So integrating the innermost integral with respect to z, first treating x and y constant, right? So if I am taking this particular integral to find its volume, so what I do is I integrate the innermost integral with respect to z, first treating x and y as constant. Next integration is performed with respect to y, keeping x as constant, and the outermost integration with respect to x. So what I do is I integrate this first with respect to its limiting points over dz. Then what I do is I take this integral after evaluation, okay, and integrate it with respect to dy, and then finally I will take this outermost integral, right? Now let us see some basic examples of triple integral, right? Okay, now these are the examples, some basic example to make you things confident about how to evaluate the integrals, right? Now this thing is evaluate, that is the given triple integral over the given function, that is x plus y plus z dz dx dy, right? And over the limit 0 to 1, 0 to 2, 0 to 3. So these points are what? These are the limiting points are what? It is constant, right? So since it is constant, so you need not worry. So whatever the order of integration is given with respect to what, okay, so you need to evaluate it first with respect to dz, then with respect to dx, and then with respect to dy, right? So first what I do, I take this innermost integral and evaluate it with respect to z, right? Since x and y, treating x and y as constant, so if I take x and y constant and if I integrate it with respect to z, so here integration of this 1 turns out to be z, and integration of z turns out to be z square by 2, and then I evaluate it for, that is over the limit 0 to 1 into dx dy. Now if I substitute the value, that is 1 upper limit 1 and lower limit, that is z minus, that is 0. So this is that is upper limit minus lower limit, then 1 by 2 I take it outside, so this turns out to be, that is 1 minus 0 over, that is dx dy. So after simplification I get x plus y plus 1 by 2. Then what I do is, again I take this integral and evaluate it with respect to dx, so keeping y as constant, right? So keeping y as constant, this is constant, right? So I take it here, so integration of x is x square by 2 and y plus 1 by 2 is constant, so it is x. So evaluating over upper limit and lower limit, so 1 by 2 of this I will take it outside, x, so upper limit is 2, so 2 power 4 is 0, so this is upper limit minus lower limit, plus I will take this constant as it is and then evaluate it for upper limit minus lower limit, that is for x, right? And finally I get this integral which I evaluate over 0 to 3, this is my given function with respect to dy. So 2 integration of that is 2y, and 2 plus 1 it is 3, so I rewrite it, and then taking integration, so it becomes 2y square divided by 2 plus 3y over 0 to 3. This 2 gets cancelled. Finally after evaluating you get the answer, that is 18, right? Okay, fine. Now so it is as simple, so you can try this for homework, this problem, and answer is given. Please check this answer, it might also be wrong, so you people need to check it, and please let me know whether it is correct or wrong. Okay, now again here too we have no issues, because already the points are given, and which are 0 to 1, 0 to 1 and 0 to 1 over, that is over some part, that is dx dy dz, and this is the given function, right? So given function, so let me consider that I is equal to the given integral over 0 to 1 and the given function e raised to x power e raised to x plus y plus z over, that is dx dy dz. Now by laws of indices I can express this given function in terms of e raised to x, e raised to y, e raised to z, right? Now the first thing is I need to evaluate this particular given function, okay, this in given integral with respect to x, keeping the other two factors constant, that is e raised to z and e raised to y. Since this is constant, so e raised to x, that is integral of e raised to x, is e raised to x only over the limit 0 to 1, right? So e power 1 minus 0, right? Then e power 1, so anything power 0 is 1, so e minus 1 I will take it outside, and then I will integrate it with respect to dy, right? So that is e raised to y 0 to 1. Again it will turn out to be e power 1 minus 1. So again I will take it outside, so it becomes e power 1 square. Then again I will evaluate it with respect to dz. So e raised to z 0 to 1, and this is one more e raised to minus 1 will come out, so it becomes e raised to minus 1, right? So the final answer will turn out to be e minus 1 the whole cube, right? And this turns out to be a solution. Okay, now the next problem is that is given as this. So here also it is constant over the function that is x square plus y square plus z square dx dy dz. Then the given equation, first I will integrate it. Here I did not write dy and dz. Please write it up. So integration of x square is x cube by 3, and this is constant. So integration of 1, it is x over the limit that is 0 to c. If I substitute this as upper limit, so eventually if I substitute 0 over here, so it is 0, so I need not write it up. So it becomes c cube by 3 plus y square plus z square into c dy dz, right? Then what I do is I take this integral and evaluate it with respect to y. So here it is integration of 1, it is y, so I am writing c cube by y plus, so here y cube, it is c, this c I will multiply over here, fine. So it becomes y, and this is y square, integral is y cube by 3 and c plus z square c into y over the limit that is 0 to b, right? Then after evaluating it, that is upper, see again here I will substitute it for what it is y. So if I substitute the lower limit as 0 0 0, so I do not include it up, only the upper limit I will include it. So c cube, that is b by 3 plus b cube c by 3 plus z square c by b over dz, right? Now finally if I substitute this, so here it is constant, so integration of constant is z, integration of here also the constant is z, and integration of z square is, it is z cube by 3. Finally I get c cube ba divided by 3 plus b cube ca divided by 3 plus e cube cb divided by 3. So this turns out to be a final answer, right? Okay, similarly let us move on to the next problem. Here too we do not have any issues because these are constant. Okay, so first thing is I will evaluate this with respect to z. Okay, so if I evaluate this with respect to z, so here it is x square, so it is z, right? Y square, it is constant, so constant is z, and z square integration is z cube by 3 over the limit minus a to a. Now this is upper limit minus lower limit, so this is again upper limit minus lower limit. Here it is minus, it becomes plus, and again here it is upper limit minus lower limit with respect to, that is dy by dy dx. Now after evaluation so this is the evaluation of z with respect to its limiting values. Therefore integrating it with respect to y, so I get 2ax square. So this turns out to be 2a over here, this turns out to be 2a, and this turns out to be 2a cube by 3, right? So integration of y square turns out to be, that is y cube by 3, right, over the limit minus b to b. Then again it is upper limit minus lower limit, upper limit minus lower limit, upper limit minus lower limit. So after evaluating I get, okay, now this I will integrate it with respect to x now. So it will give me, that is x cube by 3 here for integration of x, and 4ab, that is 2b, and that turns out to be 4ab, right? Similarly here I will get, that is 4ab cube divided by 3 x and 4a cube b divided by 3 x, integrating over minus c to c. So this turns out to be, that is 4ab c cube by 3 plus c cube by 3 plus 4ab cube divided by 3 into c plus c. Okay, so after evaluation of this you get, that is 8ab c cube plus divided by 3 plus ab cube c divided by 3 and 8a cube b by bc into divided by 3. So finally taking 8abc common outside, and inside I have that is a square plus b square plus 3, and this turns out to be a solution, right? Okay, now this problem, see this is the, I need to find the volume or evaluate this triple integral. So it is integral for the given function x dz dx dy, and the limiting values are 0 to 1 by 1 minus x, y square to 1, and 0 to 1. So let me consider this as let I is equal to, that is see here, how is this function expressed? It is 1 minus x, so eventually it is z is equal to, that is 0 to 1 minus x. Then here it is y square, so it is x square is equal to y2, and here it is y is equal to 0 to, that is 1, because here my given x is in terms of y square, and here obviously it is z is equal to 0 to 1 minus x, and finally what is left out? Y is equal to 0, that is a variable which is left out, that turns out to be the constant. And that is the reason I have said you that the formulation may change, because in the previous when I was explaining the concept, it was x, y, z, because x values were that is constants, right? So now see the pattern, same as the double integral, you should never skip the pattern. So first it is dz, so integration of xz, so x is constant, so integration of x, that it turns out to be z, and over the limit, that is 0 to 1 minus x dx dy. So upper limit is 1 minus x, okay, and lower limit is 0, so I do not write it up. So I will write that this equation as x into 1 minus x, right? So on evaluating it, it turns out to be x minus x square over dx. Now x is equal to, that is x is a function in terms of y, so y square to 1. So what I'll do is integration of x is x square by 2, and integration of x square integration of x is x square by 2 minus integration of x square is x cube by 3 over the limit, that is y square divided y square to 1. Therefore on simplification, if I substitute this, this turns out to be your upper limit, and this turns out to be your lower limit. Then again minus sign over here, right? And upper limit, that is y power 4 divided by 2, okay, upper limit in this particular thing, minus lower limit, right? Therefore on evaluation you get this particular output, okay. Then what I do is, again still one more limit value is that, so I will evaluate this given particular function and evaluate it over 0 to 1, right? Therefore on evaluating it, so y power 4, that is 1 divided by 6, integration is y, minus y power 4 is it is 4 plus 1, that becomes 5, and into, that is divided by 5, this is 3 over here, okay. So 3 is constant over here, so y power 6 is y power 7 divided by 7. Therefore substituting it for upper and lower limit, I get my solution as 4 into the 4 divided by 35, right? Now that is come to this problem. Now see here, this problem is okay. Now this problem is expressed, see this, the given problem is, that is the given function is expressed in the form of e raised to x plus y plus z dz dy dx. Now see here, now taking what limit, suppose this is dx dz dy, so in examination suppose this part is not given, because since I have written it, so you people are taking it down or noting it down or seeing it up, right? See here, first thing is you should note this limit points is expressed in terms of what? See, x and y variables are expressed, so definitely it is z is equal to x plus y. Since this is x, so definitely here it is y is equal to, right, y is equal to 0 to y is equal to x. Since y, z are variables which are there, and one more variable which is left out, so it is x equal to 0 to a. So this is how you should figure it out, right? Once if you figure it out properly, then there is no problem of evaluating, okay. Now now 0 to x plus y, so let me write my integral in the form of, that is integral e raised to x plus y. By laws of indices I can write this as e raised to z, and I can evaluate it with respect to dz, right? So keeping this term as constant, so e raised to z is e raised to z only. And see here, if I take this as upper limit, that is x plus y, so x plus y minus anything power 0, it is that is 1. So again what I do is, again we have, I multiply this here, so it becomes e raised to 2x e raised to 2y minus e raised to x e raised to y, right? And dy dx. So what I do, again I take this integral and evaluate it keeping x as constant, right? So e raised to 2x is constant, I evaluate this, so e raised to 2y divided by 2 integration over the limit y is equal to 0 to x, and minus e raised to x, then it is e raised to y over the limit, that is 0 to x and dx, right? Now upper limit is e raised to 2y and lower limit, this 1 by 2 I have taken outside, right? And y, if I substitute here, it becomes e raised to 2x minus 1. Similarly e raised to x, I take it outside, that is constant, then evaluate upper limit is e raised to x over here for y, and then substitute, if I substitute 0 over here, it turns out to be e raised to x minus 1. Then again if I multiply this, this becomes e raised to 4x divided by 2 minus e raised to, that is 3 by 2, that is after evaluation, right? You get this thing, that is e raised to 4x divided by 2 minus 3 by 2 e raised to 2x plus e raised to x. Therefore on integrating it with respect to x, right, so this turns out to be e raised to 4x divided by 8 minus 3 e raised to 2x divided by 4 plus e raised to x over the limit, that is 0 to 8. Therefore on substituting, this is upper limit, this is lower limit, and finally you get this particular answer. Right? Okay. So my next problem is evaluate over the integral 0 to x plus log y, 0 to x and 0 to log 2. Okay, fine. So see here, the given function is expressed in terms of x and y obviously. So let me consider this given integral, it is z is equal to x plus y. Here it is x, so y is equal to 0 because z is already there, so you cannot take x over here, so y is equal to 0 to x, and x equal to 0 to log 2, and this is the given function. So and this is the pattern which you need to follow. If it is dx over here, then you need to integrate it with respect to dx. Now here it is dz, right? So taking x and y as treating it as constant, not taking constant, okay, treat this as constant while evaluating it. So e raised to z then e raised to z over the limit, that is z is equal to 0 to x plus log y. Then if I take this upper limit minus lower limit, it turns out to be e raised to x plus log y minus 1 dy dx. Okay, also we know that e raised to log y is equal to y because here the base is e, and that is the, by property I can write it as, that is y, right? Then here if I take the, if I take it as e raised to x and this as e raised to y, so when I multiply this, okay, so this I can write it as, that is e raised to x into e raised to, sorry, it is log y. So what is the value of this? It is y, and that is the reason I can write it as e raised to x into y. So after evaluating it, right, so this becomes e raised to 2x, and y is what? Y is e raised to log y, that is here, and e raised to y, and here it is my multiplication sign minus then again this can be written as e raised to x, e raised to y. Okay, fine. Now what I'll do is I will integrate this particular integral with respect to, that is y, over the limit 0 to x. So keeping that is x as constant, so e raised to 2x constant. This is by integrating by parts, so you take, or else you take di method, right, which I have already told you, right? And then this is y over here, and then this is 1, and then this is 0 over here. Here it is e raised to y integration, and here it is e raised to y. So if you take this cross arrows here and then cross arrows over here, followed by plus, minus and plus, So y into e raised to y minus, see, and that is the reason I have written y into e raised to y, these two things, and then minus e raised to y minus so e raised to x, and the integration of e raised to y is e raised to y. This is what I have written, right? Okay, fine. Now evaluating it, so upper limit minus lower limit. So here if I substitute x over here, this turns out to be upper limit, okay, minus lower limit for this particular thing. And then again if I substitute, okay, for this particular thing, upper limit minus lower limit, fine. Yes, so therefore, okay, and this is like, wait just a minute, yeah, so this is upper limit. I am substituting y as x, y as x, y as x, so this is upper limit, right? And for the same thing, if I am taking minus, this is my upper limit and this is my low, sorry, here this is my upper limit and here it is my lower limit, because if I substitute y is equal to 0, this term turns out to be 0, and if I substitute here, it is minus anything power 0, it is 1. So this is for this particular thing over here, that is this simplification, right? Okay, now here I have taken minus, so minus sign will retain here. Again there is I have to substitute the limit, that is e power x, okay, I have to only evaluate it for, that is e power y variable. So y variable, if I substitute x over here, it turns out to be e raised to x minus that is anything power 0, it is 1, right? Now after simplification I get, that is x e raised to 3x minus e raised to 3x plus e raised to 2x minus e raised to 2x plus e raised to x over the limit, that is 0 to log 2. Much more again if I simplify this, okay, so that is, it turns out to be x e raised to 3x minus e raised to 3x plus e raised to x. Therefore integrating it with respect to x, sorry, so this turns out to be, therefore, okay, so the value turns out to be, this is u by v rule, right? So here this value turns out to be x into e raised to 3x, this is by u by v rule, uv rule, that is integration by parts, right? So this you get, then here it is minus sign, so I am taking minus sign, e raised to 3x is e raised to 3x divided by 3, and integration of e raised to x is e raised to x only, right? Now integrating it over the limits, that is 0 to log 2. So wherever there is so again if I simplify this, because e raised to 3x and e raised to 3x divided by, so again if I take this, so it turns out to be 4 e raised to 3x divided by 9, okay. So see here, now upper limit is what so I will take it for this, so this is my upper limit, this is my lower limit. So log 2 is log 2, in place of x I am writing log 2, then e raised to 3x, okay, so it is 3 log 2, this is my, and divided by 3, okay, minus sign, 4 by 9 constant I take it outside, e power 3x is e power, that is 3x, that is 3 log 2 minus 1, because lower limit anything power 0, it is 1. Then again if I take this, right, plus sign, e raised to 3x, e raised to log 2 minus 1. So this is upper limit, lower limit, upper limit, lower limit. Now see here, log 2 I can write it as it is, but e raised to, see here, e raised to 3 log 2, I can write it as, let me write this, what is n log p, right? So what is n log p? It is always given as log of p raised to n. Now see here, what I'll do is I will take this 3 to this power, right, and 2 power 3 is 8, so this turns out to be e log 8 you can write, or 2 power 3 you can write, and always here it is e, the bases are same, therefore the value turns out to be 8, right? So this 8 and log 2 divided by 3, similarly this is 8, yeah, 8 minus 1 I can write, so 4 minus 9 divided by 8 minus 10. Log 2 is, see, bases are same over here, so here if it is log so here it is log 2, so here e power it is not e log e, so e power log 2 to the base e. Now the bases are same, then you can write it as 2, right? Finally, after evaluating, you get this particular answer. Fine. Yes. Okay. Okay, the next problem is evaluate over the integral and for the given function r, dr, d theta and dz. See here in the previous example of that is double integral, the given expression was in the form of x, y, and or it might be in the terms of r and theta, right? Now here the given expression is given in terms of r, theta and z. So any given function, so it can be expressed as, that is f is a function of r, theta and z, right? Okay, now see here, what did I, okay, over the limit, and what are the limit values? That is 0 to a square minus r square divided by a, and 0 to a sine theta and 0 to pi by 2. Now how to take the values to which it belongs, to which coordinate, to which axis it belongs. Now see here, obviously if you had paid attention in the double integral, just have a look. See, this is 0, and that is 0 to pi by 2, obviously this will be theta. So here if you are there, this is r, theta and z, if you are taking for this particular. Now theta is there, okay, so theta is gone now, so theta value is from 0 to pi by 2, so it is a triple integral, right? Okay, now see here, what did I say? This value I will write it as r is equal to 0 to a sine theta. So r is always a value from the origin to any given, that is, point which lies on the curve. So any point over here, any point over here, any point over here, so it is obviously a sine theta, right? So a sine theta, one of the problem also we have solved, right? So depending upon theta, so theta is 90 degrees, and what, at what particular distance, that is at that is a is equal to 1, 2, 3, 4, right? And obviously therefore what do we have now? That is r is equal to 0 to a sine theta. So what is left out? Obviously z. So z is expressed in terms of what? It is expressed in terms of r and theta also, and the constant a. So that this is the equation given, right? So a square minus r square divided by a. Now we need to follow the pattern, so it is dz, so I will evaluate it with respect to dz, then r, then d theta, right? Now here, so integration over, I will not say this again and again, so I have an observation r, integration, so it is 1, so z over power over the limit, that is 0 to a square minus r square divided by a dr d theta. So if I substitute r and z upper limit, so it becomes a square minus r square divided by a, and if I substitute 0, I do not write it up, so this turns out to be my output after evaluating this particular limiting values. Now dr d theta, now what I'll do is I will take dr, right? Now therefore a square, right, a square minus, that is yeah, so this r square, what I'll do is I will multiply over here, right? So this a square I am taking outside, right? A square I am taking, see, 1 by a of this particular thing I have taken it outside, and from here I am taking a square outside, and that is integration of r is that is r square by 2 over the limit 0 to a sine theta minus, then this r square again I multiply here. So see here, already I have taken this 1 by a over here, okay, so this turns out to be r square divided by 4 over the limit, that is 0 to a sine theta, and the whole thing into d theta. Therefore on evaluating you get this particular thing, that is a power 4 divided by 2 sine square minus sine square theta minus a power 4 divided by 4 sine power 4. So do not solving is this particular given equation. So you have a standard form, and as I said, always the integral if it is of the form 0 to pi by 2, and if you have sine square or sine raised to n theta or cos raised to n theta, depending upon the value of n, whether it is even or odd, so using that is 0 to pi by 2 sine n theta and d theta n minus 1, and finally you should stop your answer till you get that is 1 by 2 and multiply it by pi by 2. So therefore after evaluating, see this a by 4 divided by 2, I write it here as it is, fine, and then sine 2 is even, so 1 by 2 obviously, so it is 1 by 2 pi by 2 minus, I will take evaluated for this particular integral, so a power 4 divided by 4, 3 by 4, 1 by 2 and pi by 2, right? Therefore on evaluating it, so this turns out to be my final answer, this thing. Okay, now this thing, let me check whether I can give it for homework. Yeah, this you can do it for homework. Okay, very simple. See here xz, so obviously here it will be y is equal to z, right? So y is equal to z, so z is here, so obviously this is x is equal to, and this is z is equal to, getting? And finally evaluate it, so you should follow the pattern, so it is pi dy x dx and z dz, right? So just see this. At any instant if you do not understand, please feel free to ask the questions. We are there to help you out. Right, now this equation, so evaluate that is 0, that is given function x plus y x y z dz dy dx over the limit that is 0 to square root of 1 minus x square, so this is expressed in terms of x and y, so obviously it is z is equal to, this is expressed in terms of x, so obviously this is y is equal to, and this is x is equal to, right? So follow the pattern, right? So I will not keep on telling you the concept again and again. So evaluation part, it is very easy, so keeping treating x and y constant, and integration of z is z square by 2 over the limit 0 to 1 minus x square minus y square, right? And then if I substitute this, so xy, so 1 minus, so this is this square and this square root sine square gets cancelled, so it turns out to be 1 minus x square minus y square dy dx, right? Then again what I do, I multiply this inside, so xy square, so it is with respect to dy, right? So again if I multiply after evaluating this, I get this particular output over the interval y is equal to 0 to square root of 1 minus x square into dx. Then again I simplify this. Okay, so again if I take this of that is simplification, and over the limit, that is still I did not apply the limits, that is y is equal to 0 to square root of 1 minus x square, so y square is here, y square is here, y power 4 is there, so this square root sign gets cancelled, so 2x 1 minus x square minus 2x cube 1 minus x square minus x into 1 minus x square the whole power, that is square, right? Therefore after evaluating this I get this particular answer. Therefore again it is 1 by 8 integration from x equal to 0 to 1 x power 5 minus 2x cube plus 6 dx. Now after evaluating, so I get my output as 1 divided by 48. Okay, so now we have an important concept, that is, let us see same as the case what we have done in change of variables in double integral. Now we shall extend it with the same concept, that is change of variable in triple integral, right? Now let us see the relation between Cartesian coordinate x, y, z and u, v, w are as follows. There it was x, y and u, v, so transformation was taking place from x to u, v, right, as follows. So x is a function which is expressed in this particular manner, that is phi1 UVW, and y is also a function which is expressed in terms of phi2 UVW, and z is equal to that is phi3, so it is expressed in UVW. So then the Jacobian for this transformation is, so this transformation I have explained you. Suppose if this is similarly if u, v, w are functions of independent variable x, y, z, but here in our case it is x, y, z in terms of u, v, w. So you can take this Jacobian in this particular manner, right? Take its determinant. Okay, so here hence the volume that is f of x, y, z dx, dy, dz will definitely change into this particular limit, that is dx, dy, dz is nothing but that is magnitude of that is Jacobian j do u do v, and that is du, dv, dw, and over a new function that is f in terms of x, phi1, phi2, phi3, and also changing the limits of this given integrand. The region of integration v in x, y, z is covered by limits of u, v, w, and it is denoted by v. Okay, so understood this? Same concept. That is the reason you should know double integral first, right? This is important. Now in the previous section, should I go to my previous section? Yeah, not this. Yeah, now here in the change of variables, what we have done, we have expressed x in terms of r cos theta and y in terms of r sin theta, right? So a polar coordinate can be transformed into Cartesian coordinate or Cartesian to a polar coordinate, right? Now same is the case over here, that is for triple integration. Okay, so change of variable of that is variables from Cartesian to, this is important, Cartesian to polar coordinate. There it was x is equal to r cos theta and y is equal to r sin theta. But now if we take that is x, y, z to that is spherical polar coordinate, so x is equal to r sin theta cos phi, right, and y is equal to r sin theta sin phi, and z is equal to r cos theta. Therefore by taking the Jacobian of this, so we get finally that is r square sin theta. Therefore for some part of the, that is if you take this x, y, z, and if this is a sphere, and if I take some part over here of this sphere, any part, right, existing on this some part of this sphere, then it turns out to be that is Jacobian of dr d theta d phi. So what is Jacobian? Jacobian is always given by r square sin theta dr d theta d phi. Spherical coordinates are useful when the region of integration is a part of sphere. Okay, now this is all about that is Cartesian to spherical coordinate, so you just remember this. Fine. Okay, now change of variables from Cartesian to cylindrical coordinate system, right? Now we have x equal to r sin theta and y is equal to r cos theta, r sin theta, and x equal to r cos theta, and z is equal to z. Therefore the Jacobian j is r. So dx, dy, dz is replaced by Jacobian, that is r dr d theta dz. okay, and then it can be used for problems of solving, that is cylindrical surface, right? Now, so basically formula for computing volume of triple integral is, that is for Cartesian coordinates, it is always given by, that is a region or the volume over, that is dx dy dz. Now for spherical that is geometry, so what you have, the volume or the region is always calculated as r square sine theta dr d theta d phi. Also for cylindrical body or the figure, we have, that is for finding volume of cylindrical structure, we have r dr d theta dz, and this is the region. Okay, now let us move on to the problem, and problems are easy once if you understand, have the knack of taking things, that is changing to, that is Cartesian to polar coordinates. Now this is a Cartesian coordinate given, this is in terms of x, y and z. See here, obviously, so this is equal to, that is, okay, I did not show you the figure of sphere. So sphere is this, that is 3 dimension, and this is what, see here, right? Here it is x equal to r sine theta cos theta, so along x is direction, and r is equal to r sine theta sine phi, okay, and here it is z is equal to r cos theta. Fine. So here coordinate system can be transformed into, that is polar coordinate, or a polar coordinate can be transformed into, that is Cartesian coordinate, and this is the figure. So this point P is nothing but it lies anywhere on the circle, right? Fine. Okay, now here I need to change this from Cartesian to polar coordinate. Now if you can see so this, okay, so if suppose if you do not know this, so what you're going to do, say x is sorry, so the upper limit here it is expressed in terms of x and y, obviously it will be z is equal to, so it is expressed in x, right? So it is obviously y is equal to, okay, and here it is x equal to, that is the reason I said that every time formulation of the concept may change, right? So what is the value of x? X value is ranging from 0 to 1, which is constant, and I have written here. What is the value of y? It is written as, that is y is equal to square root of 1 minus x square, right? And what is the value of z? Z value is 0 to, that is square root of 1 minus x square minus y square. See here, equation of sphere is like, this is a circle, fine, and then I am talking about a sphere. This is a 3-dimension figure, so it is x square plus y square plus z square is equal to 1, right? Okay, so it is this particular equation, fine. Now sorry, in this z is equal to, no, so if you are taking z is equal to square root of 1 minus x square minus y square, so this square root sign will come here, it will be z square, right? So z square here, x square here, and this side y square, right? So it becomes z square plus x square plus y square plus z square. Now this gives the region of a positive octant of the sphere. Now what do you mean by positive octant? And see here, positive octant, before to that I would like to, where is that figure? See here, if you cut this given circle in 2 parts, this like this, vertical and horizontal, total how many sections are you going to get? You're going to get 8 sections because it is sphere, right? So total 8 section you are going to get. Now this particular thing will be your for problem domain, right? Okay, now here, therefore this gives the region of a positive octant. So this was a positive octant of the sphere. So this positive octant, so how much octants do you get? That is, you get, see, this is one of the octant. If you cut it vertically and cut it horizontally, that is the given sphere, one you get total 8 octants, right? And positive octants in the sense, we have, where is it? Yeah, see here, in your schooling level you people have studied, right? That is 3-dimension geometry. So in x, o, x, y, z, so only how many octants you have? 8 octants, right? So here you have, that is plus, plus and plus. Fine. Now okay, so here this gives, okay, if x is equal to r sin theta cos sin phi and y is equal to r sin theta sin phi, you are that is since this limiting value is from 0 to 1 and 0 to, okay, so here the values are given as, that is 0 to 1, okay, and 0 to square root of 1. So what I'll do is I will take this equation of the sphere. So equation of the sphere is given by x square plus y square equal to z square, which is equal to 1. If x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos phi, then also we have dx dy dz. Dx dy dz can be written as, that is Jacobian as that is r square sin theta dr d theta d phi, and the given, that is equation, that is x square plus y square plus z square is equal to r square. Now for the positive octant, that is I was discussing only about this, here it is plus, for only positive octant, total there are 8 octant, right? Okay, so evaluating only for positive octant. So what will happen to r? R will obviously turn out to be, that is 0 to 1. See here, how does it trace? So it, what is the value of phi? Phi will be, that is 0 to pi by 2, and theta value will be, that is 0 to pi by 2, right? Now this particular value, see here, this is a starting point. So x is ranging from 0 to 1, y is ranging from 0 to square root of 1 minus x square, so z is from 0 to square root of, that is 1 minus x square minus y square. This gives the region of octant of the positive, that of the sphere, and x square plus y square plus z square is equal to 1. Now if x is equal to r sin theta cos phi and y is equal to r sin theta sin phi and z is equal to r cos phi, then this dx dy dz is equal to r square sin theta dr d theta d phi. Okay, now and the unit circle, that is sphere, x square plus y square plus z square is equal to r square. Now see here, now it so happens that therefore the positive octant of the sphere, unit sphere, will be r is equal to 0 to 1, theta is equal to 0 to pi by 2, and phi is also an angle, theta is also an angle. Just to distinct between these, you have given in terms of, that is theta and phi. So theta is from 0 to pi by 2. See here, what is z is expressed in some angle, right? Okay, so phi is an angle, and now if you take, where is that? Yeah, now this is the octant, that is positive octant. Fine. Now how is this theta varying? Theta is varying like okay, if you take z axis, suppose this is phi, see here it is phi, so it is coming like this. So it is obviously, it is towards this, so it is making an angle, what, it is from 0 to pi by 2, this pi that is, it is moving like this till here. So what will be the angle formed here? It is pi by 2, and it will trace all the points in this particular octant, on this particular octant. Okay, fine. Now that is the reason phi is 0 to pi by 2. What is happening to theta? Theta also is as same, that is the value of, sorry, see here, what is the value of theta? So theta also varies from what? See here, it also varies from, that is if this is x-axis, sorry, y-axis, so it also varies from, that is pi by 2, right? Now, and therefore finally r is a point from the origin to at a distance of a point. So therefore r is obviously x, x if you take the value, so definitely it turns out to be 1, right? Now therefore the given limiting that is integral of this particular type, now after changing the limits, you have 0 to pi by 2, 0 to pi by 2. Whenever you find this particular integral, so it is obviously an octant, and the figure of this octant is this type, right? Okay, now they have only asked you to solve the problems for positive octant. Suppose if they have asked you to find the complete that is area volume of the sphere, so what you can do is, this is just I'm saying it to you, so just multiply it by 8. You take only one positive octant, evaluate it with respect to any given function, right? And this, if you find this particular thing, then multiply it by 8. But see that you should understand the question first. Please simply don't write it, right? Okay, now here it is 1 divided by, so 1 minus x square plus y square minus z square is r square. And what is this dx dy dz? So transformation, this is its Jacobian, which we have already calculated, r square sine theta. So d phi d theta dr. Now this is with respect to, that is first I am going to evaluate it with respect to d phi, right? So d phi keeping what constant, that is r constant, theta constant. So r square sine theta divided by square root of 1 minus r square over phi. So integration of 1, it turns out to be phi over the limiting points 0 to pi by 2, then upper limit minus lower limit, then integrating again with respect to theta. So this turns out to be, that is r square square root of 1 minus r square. I will keep it outside, treating r as constant. Sin theta turns out to be minus cos theta over the limit 0 to pi by 2 dr. So if I substitute this value, 0 minus 1, right? So this turns out to be, now still what I do is, I need to evaluate this particular integral. So what I do, I make certain arrangement, that is if I substitute r is equal to sin theta, so dr, differentiating it with respect to, that is r, so dr into which is equal to cos t dt. So if r is equal to 0, so if I substitute here, so t is equal to 0. If r is equal to 1, then t is equal to pi by 2. So what I do is, so integration of this is, so it is r is equal to 0 to pi by 2, then r square is sine square theta square root of 1 minus r square. Okay, so this turns out to be sine square t into cos t. Okay, therefore sine square t into that is okay, after substitution, so this turns out to be, that is sine square t divided by square root of 1 minus sine square t cos t dt, right? Now here it turns out to be, that is square root of, so what is square root of 1 minus sine square theta? So it turns out to be that turns out to be cos square theta, right? Cos square theta, right? 1 minus sine square theta can be written as cos square theta. So square root of cos square theta will give you cos theta, right? And today my writing pad is not working, so here this turns out to be, that is cos theta. So this cos theta and this cos theta gets cancelled out. Now what I'll do is, I will write sine square theta. Sine square theta can be written as 1 minus cos 2 theta, that is divided by 2, okay, multiplied by 2, and this 2, right? 2 sine square theta can be written as, that is 1 minus, there is one formula, I hope so, right? Therefore the formula for this is, that is sine square theta. So what I'll do is, that is I will multiply 2 over here and then 2 over here, so that is 2 sine square theta is equal to 1 minus 1 minus cos 2 theta. So here this turns out to be this, okay, fine. So 1 by 2 so 1 minus cos 2 theta, so 1 by 2 is already here, so I'll take it outside. So after integrating, so integration of 1, it turns out to be t cos 2 theta sin 2 theta by 2 over the limit 0 to pi by 2. Therefore after evaluation I get an answer, that is pi square by 8. Okay, now let me check okay, this problem, yeah. So evaluate. See here it is given as this is volume, okay, so I need to dx dy dz divided by x square plus y square plus z square, where v is the volume of the sphere. So volume of the sphere, you know, that is x square plus y square plus z square is equal to a square. If d is the region of positive octant, so the very first thing when you hear positive octant, so definitely what you need to find, the complete volume you need to find. If d is the region of the positive octant of the sphere, that is x square plus y square plus z square equal to a square, then the volume of the sphere is, okay. So see at this time it is 8 times. So what you know, do you know the limit limiting values? No. So that is integration from over this domain, that is d. This d is what? It is the positive octant. So one part of the octant I am taking, and that is, this is my sphere. So what I do is I cut this sphere like this into two, from here and here. So totally how many octants you get? You get 8 octants. This is just a plain figure, but it is actually a 3-dimension figure, right? And finally you have this particular octant. Now it is positive octant, and as I said, you have learned that concept in your 3-dimension figure. Totally 8 octants you have, right? So the total 8 octants will be of what? One will be plus x will be plus y plus z plus. If x is minus y plus and z plus, then so these are all 8 combination, that is x y o is nothing but here it is origin, right? O x y z, o x prime, that is here it is negative, here y is negative, here z is negative, here x y is there negative, right? And so on. Similarly, so d is my what? Only positive octant, so I will include. So since it is positive octant, so it is 0 to pi by 2, 0 to pi by 2 and 0 to a into 8 times, right? So that I can find the complete volume of this given particular function, right? So definitely here it is dx dy dz can be written as that is r square sine theta d phi d theta dr. Therefore similarly I hope you can evaluate this. So after evaluating it with respect to d phi, after evaluating it with respect to d theta, after evaluating it with respect to dr, okay, and finally you get this particular answer, right? Okay, yes. So this is for your homework. At any instant you're not able to do it, then I am there to help you out. And this particular problem basically it comes in application, okay. So only the thing is and yeah, so what you should understand, that is change of this is what I was discussing, okay. And this particular part, only this thing you should know, that is this formula you should know. This is important, like this, okay. How do you change it? And apart from this, how do you change it for that is Cartesian to spherical coordinate and Cartesian to cylindrical coordinate, okay. Now what I'll do is I will take one problem of cylinder, and yeah, this is the equation, okay. So this is also I hope this should be done to you. See, find the volume of common volume common to the sphere. So please read the question properly. Find the volume common to the sphere, okay, that is x square plus y square plus z square is equal to a square, and the cylinder. So cylinder is given in this particular manner. So we shall okay, so see here the figure is here. So common to both, that is x square plus y square is equal to ax. We shall solve this example in terms of cylindrical coordinate, right? So what I do is, that is by, as I said, if you are solving it by in terms of cylindrical, you can also solve it in terms of spherical coordinate also. I have given, yeah, this, see this change of variables from Cartesian to cylindrical coordinate. Now what I do is, so if I am taking cylindrical coordinates, therefore I have to transform it from x to in terms of r cos theta. So x is equal to r cos phi, and y is equal to r sin phi, and z is equal to z. This is what I have given here. Yes, okay, fine. Therefore so here theta, there I have taken theta, here they are taking phi. Okay, for the given region z varies from, see here, now if you see this figure, what is happening to your z? See here, z is varying from, that is minus square root of see here, if you take this sphere equation, so this part, okay, this part of the sphere, like, sorry, this part if you are taking, right? So what is happening for the sphere, if you take this equation, right? So here it is z square is equal to, if this x square plus y square I take it to the other side, it turns out to be, that is a square minus x square minus y square. But eventually what is the value of x square plus y square? It is r square. So what, in short, what I am going to do is, I will take this particular thing, that is, I will write, can I write it as a r square? Okay, therefore if I take the square root side, and then this turns out to be, that is square root of a square minus x square. So what is happening to the value of z? So so from the given region, z varies from, see, from this region to this region, so z varies from, that is, this turns out to be plus or minus. Okay, now yeah, and this is the common shaded region that is included between the sphere and the cylinder. Now here, and r varies from, so what is the value of r? R value varies from, that is 0 to cos phi. See here, I will take this particular equation. Now this, see, z varies from, that is z is equal to minus square root of here, minus square root of a square minus r square, and that is from this position to this is z axis, right? Complete. Okay, and now I want to find the value of r. What did I say? Value of r varies from, usually it varies from, that is 0, that is from the origin to the curve. Now this is the given curve. Now see, first it was 3 dimension, now it comes to 2 dimension, because it is a triple integral, right? Now what is the curve? See, this x square plus y square, I can write it as r square, which is equal to a. What is the value of x? A value of x is r here, can you see? That is cos phi. So this r and this r gets cancelled, so value of r is what? R is at a distance a cos phi, and that is the reason I am writing here, that is r is at a distance, r is equal to 0 to cos phi. So please pay attention. And finally, what will be the angle? Angle will be, that is 0 to pi, that is 0 to, that is, it is moving like this, right? So complete. Fine. So understood how you are taking the value. Suppose okay, then let me come to the evaluation part. Let me have a glance. Find the volume common to the sphere, and then the sphere equation is given, right? And the cylinder is given, cylinder. Okay, we shall solve this example in terms of cylindrical coordinate by taking x equal to r cos phi and y is equal to r sin phi, and z is equal to z. For the, since z is equal to z, so what will happen from here to here? Z will vary obviously with respect to this sphere equation I am taking. Okay, so it is minus square root of a square minus r square here, and plus square root of a square minus r square. R varies from, r is from origin to this. If I take, with the help of this, I can take which value it is, that is a cos phi, and phi varies obviously from 0 to phi, and the rest of the things is in the evaluation part. So first thing is I will evaluate it with respect to z. So integration of z, see, and this here it is r d phi. How do you evaluate it? Yeah, so dr, yeah, so see here, Here it is given as the Jacobian, it is r dr d theta dz, right? Now here it turns out to be square root. See, here it is square root of, okay, so here it is square root of a square minus r square. See, it is 2 times. See, upper limit minus lower limit, minus minus becomes plus, so it becomes 2 times of square root of a square minus r square. That is the reason I am taking, that is 2 outside. Okay, now this inner integral is been evaluated. I will take it with respect to phi. So r is equal to 0 to a cos phi. So r inside the bracket square root of a square minus r square and d phi. So which is equal to, what I'll do is I will so here what they have done is they have taken an adjustment over here. So see here, now here the pattern is r, so r I am going to evaluate it with, not with respect to phi but with respect to, that is dr, right? So here what I have taken, see, this r multiply and divided by minus 2r, right? So what I'll do is 1 minus 1 by 2 I have taken outside, this square root power will be 1 by 2, right? Inside the bracket you have a square minus r square, and this r power, it will be what? It will be 1, right? So plus 1, this r power, that is 1. I hope so it is correct. No. Okay, here we have that is see here, this evaluation is done, that is square root, there is a formula for this, I know, that is, should I write it here? That is integration of, sorry, this work writing pad dash, integration of, let me okay, yeah, integration of f dash of x and f power x raised to n into dx, which will always give you f of x power n plus 1 divided by, sorry, this is n plus 1. Please write this formula. This is f dash of x, f of x power n dx, which will always give you f of x n plus 1. Now see here, what I do is this I will take minus 2r and minus 2r over here, right? And see here, this is if I take this a square minus r square raised to 1 by 2, right? So what I'll do is, okay, so if I take a square minus, sorry, not x square, a square minus r square power 1 by 2. Now see here, this is this, so n is what? N is my 1 by 2, and what is the differentiation of this f of x, this internal thing? So it is obviously minus 2r, right? So to make it a formula, for what I did, I divided by minus 2 over here, so that it is same, right? So this minus 2, and because r is already here, right? So because r is already here, I require what? Minus 2 and minus 2, that is minus 2 to complete it in a particular formula. Therefore what will be, so this is inside the bracket, that is minus 2r. So minus 2 is here, so this minus 2 I am taking here, so it becomes minus 1 by 2. Therefore it is f of x. What is your f of x? It is a square minus r square. So a square minus x square, n is half plus 1, half plus 1 is 3 by 2 divided by n plus 1, it is 3 by 2 over the limit, that is r is equal to 0 to a cos phi d phi. Then after simplification, right, so upper limit, that is this is 2, let me check again, this 2, this gets cancelled, we have 2, yeah, this becomes 4, and here it turns out, therefore this value, that is 1 by 2, this 2 gets cancelled, 2 by 3, and here if I substitute upper limit, this turns out to be 1 minus sine cube phi into d phi, and okay, which is equal to, that is 2a cube divided by 3 inside the bracket. So if I take this with respect to, that is phi, so phi upper limit minus lower limit, so it is 0, so I do not write it, it is minus pi over the limit, that is 0 to pi sine cube phi d phi. So 2a cube divided by 3 pi minus 2. See, there is a property that if the given integral is from 0 to pi, you can write it in the form of 0 to that is 2 into 0 to pi by 2 sine cube phi d phi, which is equal to, here you can apply what, that is reduction formula, that is 2a cube divided by 3 into pi minus 2 into 2 by 3, which is equal to 2a cube divided by 9 and 3 pi by 4. So this turns out to be a solution. So what I'll do is, in my next class or next lecture, I will be dealing with the concept of that is applications, right? So just go through it, and if at all you do not understand it, then please let me know. This problem is an application problem, common region. Okay, so finally what we'll do is we will solve problems on that is applications of double and triple integral. By the time you people just go through the notes and just solve the problems, try to solve the problems on your own. At any instant, if you have any problems, please let us know. Okay, thank you very much.